2015, humanity achieved something extraordinary. The New Horizons spacecraft, after a 9-year journey, flew past Pluto at breathtaking speed, giving us our first close-up look at that distant world. Yet the spacecraft didn't stop there. Instead, it kept racing outward, deeper into the Kuiper Belt, a mysterious region beyond Neptune, filled with icy remnants from the dawn of the solar system. But what lay ahead? For New Horizons, would it encounter another world? Could we hope for a second chance to witness something new billions of kilometers from home? As it turns out, yes. And the object it found would astonish scientists and the public alike. Today, let's journey together to uncover the story of Arrokoth, the most distant object ever visited by a spacecraft. What is it? How was it discovered? And what secrets does it hold about the early days of our solar system? Before New Horizons even reached Pluto, its mission team was already thinking ahead. The spacecraft still had fuel, its instruments were healthy, and its radioisotope power source had many years left. Could it continue on to explore another object? The challenge was finding one. In 2014, the team was granted time on the Hubble Space Telescope to search for potential targets along New Horizons' path. Imagine the difficulty trying to spot a tiny faint body against the endless starry backdrop billions of kilometers away. It was like hunting for a cosmic needle in a haystack. Remarkably, Hubble discovered 3 promising objects. After careful analysis, one stood out, a body about 35 kilometers long, later named Arrokoth. What made it unique was that it hadn't even been discovered when New Horizons launched in 2006. This would be the first time in history that a spacecraft's next destination was chosen after it was already on its journey. The team commanded New Horizons to make subtle adjustments, nudging its trajectory so it could intercept this target years later. At the time, very little was known. Hubble's data revealed its reddish color and slight variations in brightness as it rotated. An occultation event when Arrokoth passed in front of a star allowed scientists to predict its elongated shape. Was it a single asteroid-like body, or perhaps a pair of objects locked together? That mystery would only be solved once New Horizons arrived. 3 years after Pluto, in August 2018, New Horizons began its approach. At a distance of 172 million kilometers, Arrokoth was barely a smudge against the stars. But by December, it grew brighter in the spacecraft's cameras. Think about the scale. New Horizons was hurtling through space at 51,000 kilometers per hour. There was no possibility of slowing down or turning back. The spacecraft had just one chance, one flyby, one glimpse. Miss it, and the opportunity would be lost forever. On January 1st, 2019, while much of the world was celebrating the new year, New Horizons made history. It swept at just 3,500 kilometers above Arrokoth's surface, capturing an immense amount of data in those brief moments. At that instant, Arrokoth became the most distant object ever visited by a spacecraft, more than 6.5 billion kilometers from the Sun, about 45 times farther than Earth. The images would take months, even years to return, but even the first glimpses revealed something remarkable. Arrokoth wasn't just a simple rock. It was a strange bilobed world, shaped unlike anything we had seen before. If you're wondering why it took so long to see these images, the answer lies in distance. Communicating with a spacecraft that far away is painfully slow. New Horizons transmitted data back at just 1 kilobit per second. To put that in perspective, it's like trying to stream a high-definition movie through a 1990s dial-up modem. Because of this, it took nearly 2 years to send all the information back to Earth. The mission team prioritized the most important data-first images and key science readings. That's why, when news outlets reported on the flyby in early 2019, most of the pictures were still low resolution. Only later did the stunning high-definition images finally arrive, revealing Arrokoth in all its detail. Patience was required, but the wait was worth it. What unfolded was a frozen time capsule from the birth of our solar system. So what did those images and measurements reveal? The first striking feature is Arrokoth's colour. Unlike the dark grey asteroids closer to home, Arrokoth is a reddish hue. That colour comes from tholins, complex organic compounds created when simpler molecules are broken apart by solar and cosmic radiation. The spectra from New Horizons confirmed the presence of methanol hydrogen cyanide and water ice on its surface. Methanol, when irradiated, can create tholins, explaining the red appearance. Curiously, the data also showed an absorption band at 1.8 microns, evidence of a compound we haven't identified before. It's something new, something we've never seen, and without a physical sample, we can only speculate. Another fascinating feature is the lack of small craters. You might expect an object billions of years old to be scarred with impacts, but Arrokoth's surface is relatively smooth. Why? The answer lies in the Kuiper Belt. Compared to the asteroid belt, it's much wider, and objects move at slower orbital speeds. Collisions are less frequent, and when they do occur, they happen at much lower velocities. Instead of violent destruction, gentle encounters are more common. This has preserved Arrokoth as a kind of time capsule, a window into what the building blocks of the solar system looked like billions of years ago. Its surface also shows signs of volatile materials escaping, forming depressions that look like craters, but may actually be sinkholes. Through these clues, Arrokoth tells us about a time when the solar system was young and chaotic, yet also delicate, where icy fragments drifted and sometimes merged rather than shattered. Arrokoth's shape is perhaps its most remarkable feature. It resembles two lobes joined together like a snowman drifting in space. The larger lobe is called Ultima, and the smaller one Thule. Together, they form a classic example of a contact binary. How does such an object form? Unlike the asteroid belt, where collisions are violent and often destructive, the Kuiper Belt offers a gentler environment. Two icy bodies may have formed side by side within the same swirling cloud of material. Over time, they orbited each other, slowly spiraling inward. Eventually, they touched, not with an explosive crash, but with a speed slower than a human walking pace, perhaps just 2 meters per second. It was less of a collision and more of a cosmic embrace. The evidence supports this. There are no major fractures where the two lobes joined and their surfaces look similar, suggesting they formed in the same region. The surface shows other mysteries too. Bright regions appear in certain spots, especially around the neck connecting the two lobes. Some may be caused by avalanches of loose material. Others could be accumulations of volatile ices protected from sunlight. With a density of only 0.5 grams per cubic centimetre, Arrokoth is porous, not tightly packed. Volatile materials may have escaped its interior long ago, only to freeze again on the surface. Even its temperature surprised scientists. Models predicted it would be around 12 to 14 Kelvin, just above absolute zero. Yet New Horizons measured nearly 29 Kelvin, still unimaginably cold but warmer than expected, hinting at processes we don't yet fully understand. One final surprise emerged after scientists studied the data more closely. Arrokoth isn't just bilobed, it's flatter than anyone anticipated. At first, this wasn't obvious, because the spacecraft only saw it illuminated from certain angles. But once the data was modelled, the flattened shape became clear. Why is it so flat? We don't know. Perhaps centrifugal forces in its early history caused it to compress, or maybe long periods of uneven sunlight caused volatile materials to evaporate from one side more than the other. Whatever the reason, this puzzle remains unsolved, leaving researchers with more questions than answers. This sense of mystery is part of what makes Arrokoth so compelling. It reminds us that even when we think we've learned something new, the universe still has ways to surprise us. As New Horizons sped away, it turned back for one last look, capturing Arrokoth's silhouette against the backdrop of distant stars. Perhaps no spacecraft will ever return to this tiny world, making these images the only close-up views humanity may ever have. Yet, New Horizons is not finished. It still has fuel and power, and the team continues to search for another possible target within reach. Even if none are found, the spacecraft will one day follow in the footsteps of the Voyagers, leaving the protective bubble of our sun's heliosphere in the 2030s. Already New Horizons has reshaped our understanding of the outer solar system. From Pluto's icy plains to Arrokoth's gentle embrace, it has shown us worlds we never imagined. And if these are just the first glimpses, you can't help but wonder what else is still waiting far beyond the reach of our eyes. That was our journey to Arrokoth, a tiny frozen relic holding secrets from the dawn of the solar system. From its red organic surface to its snowman-like shape, every discovery has reshaped our understanding of how worlds are born. New Horizons continues its voyage, pushing further into the Kuiper Belt and perhaps one day beyond the heliosphere itself. Whether it finds another target or not, it has already given us wonders no telescope on Earth could ever provide. So what do you think should humanity send more missions to the Kuiper Belt to reveal the hidden diversity of these distant worlds? Share your thoughts in the comments below. If you enjoyed this exploration, don't forget to subscribe to Cosmic Compass for more journeys into space. Until next time, keep looking up, because the universe always has more stories to tell.